Let's take a look at the first example. We have v equals sine omega t. Remember, anytime there is no integer over here, there is always invisible 1. So I can say that my voltage peak is equal 1. Now I'm supposed to draw the wave. But this time my x-axis is going to be calibrated in radians. This is going to be theta in radians. This is sine wave, and voltage peak is equal 1 volt. This is my voltage in volts, and this is my 1. And I'm going to draw the dashed line in order to make the wave looking symmetrical, and I have -1 somewhere over here. Next, I'm supposed to draw the sine wave. Remember, we have very important points on the sine wave. There are, you can say, pi, and this is 2 pi. Also, the peak voltage is going to be always at pi over 2, and another peak is going to be at 3 pi over 2. Now, remember, this is 0 degrees, 0 radians, and draw the wave. This is the graph to this equation. Let's take a look at the second example. And please notice that the difference between the first expression and the second one is just pi over 4. It means that the answer for the second problem is going to have exactly the same shape like the first one, but is going to be moved to the left side. This is the phase shift angle, and anytime you have positive sign, it has to be moved to the left of your reference point. But my reference point is most of the time 0. So what I have to do, I have to move every single 0 crossing point to the left by pi over 4, and every peak point to the left by pi over 4. So let's do it. And I have to find pi first. This is approximately pi, negative pi, and I have to find pi over 4. So I have to divide this pi into 4 pieces. And this is my negative pi over 4. Next, we have to move the most important points of the sine wave to the left by pi over 4. This is my pi over 4. So it means I have to move my peak, positive peak, by pi over 4 to the left. I'm going to move my pi by pi over 4 to the left, and I'm going to move my 3 pi over 4 by pi over 4 to the left, and I'm going to also move 2 pi by pi over 4 to the left. So this is going to be my negative peak at this point, and this is going to be my positive going 0 crossing. Next, I'm going to connect all these points together. Now, we got the sine wave, which is shift by pi over 4 to the left side. And this is the solution to this problem.